sir. I am not attended, sir, studies class.
You are not written it. Yes, what about Sovik Rai? Sovik Rai.
Yes, sir.
Yeah, what is the expression for modulation index for the PM signal?
Sir, AM into K by PM.
What man? For phase modulation.
Sir, AM into K by beta.
No. Yes, quickly you should tell. Yes, are you able to see the expression? Sovik Rai?
Yes, sir.
What it is written?
KP into AM.
Man. Huh?
KP into AM.
Then what you are saying? Why you can't note down all these things, equations in your notebook properly? Why you can't study? Huh? Only teacher should study, huh? Yes, this is all done yesterday, right? You have derived what is the modulation index and expression by considering sinusoidal message signal for both FM and PM. And I think I solved one simple problem also. Okay. So this is what the summary I wrote yesterday. For sinusoidal message signal, the value of modulation index will be Kp into AM. For frequency modulation, it will be Kf into AM by FM. And I given one simple problem saying the magnitude of the message signal, frequency of the message signal, then the frequency sensitivity factor. Okay, I have asked you people to find out what is the frequency deviation and as well as the modulation index. So it is a straightforward substitution, right? Okay. So let us take some more problems for finding the instantaneous frequency. Just note down the problem. Determine the instantaneous frequency. Determine the instantaneous frequency in hertz for each of the following signals. For each of the following signals. Okay, so let me write the first one, that is 10 cos 200 pi t plus pi by 3. Yeah.
Can you repeat the question, sir?
Determine the instantaneous frequency. You are supposed to find out the instantaneous frequency is what? How do we represent instantaneous frequency? That is Fi of t, na? Yes or no? Instantaneous frequency or modulated frequency it is Fi of t. Okay, so this is the given signal. For this, we need to find out the instantaneous frequency. Yes, try to solve this. How do we go about this? So let me write two more signals also. Then we'll take one by one. Second one is 10 cos 20 pi t plus pi t square. Okay. So third one is cos of 200 pi t into cos of 5 sin 2 pi t okay, plus sin of 200 pi t into sin of 5 sin 2 pi t. Okay, so these are the three signals given. You are supposed to find out the instantaneous frequency.
Sir, we have to use the definition formula, sir, the 1 by 2 pi t.
Yeah. Definition of instantaneous frequency. What is the definition of instantaneous frequency? How do we define?
1 by 2 pi
Yeah,
d
Fi of
by
t is equal to 1 by 2 pi d by dt of theta of t, right? Or theta I of t. So you need to treat this as theta I of t. Okay, whatever is written here, 10 cos of. Okay, this part is theta I of t. Is it fine?
Yes, sir.
And treat this as theta I of t. Okay, for all the things. This also. Yeah, I expect answer from you people only. Yes, Ananta. Ananta. Ananta is there? No. Yes, what about Neeraj?
Yes, sir.
Are you doing it?
Sir, could you explain once again? I didn't get that. Which formula, sir? 1 by 2 pi?
What is the definition of instantaneous frequency, man?
Sir,
Instantaneous
instantaneous
frequency, so
frequency,
far you have not heard. Instantaneous frequency.
frequency at that particular moment or that time.
Yeah. See, how do we define that? Fi of t is equal to, what is the formula? Definition, 1 by 2 pi, right? Into d by dt of what? Theta I of
Theta.
t. I said, what is theta I of t, right?
Yes, sir. That
Just
200 pi t plus pi 3.
200 pi t plus pi by 3. Just substitute, differentiate, and you can say what is the value.
Yes.
Sir, is it 100 hertz?
Yeah, 100 hertz, very good. So you can write here I hope others also have done.
Yes, sir.
I hope it is done. Everybody has got it.
Sir, in the B problem, sir.
First one you got, man.
Yes, sir.
How much you got?
100 hertz.
100 hertz, right? Yes. I
Sir,
will
in
do the second one. First, let me ask others also. Okay, one you got 100 hertz. What about others? Who has got the answers? Yes, Nagaveni, have you got the instantaneous frequency as 100 hertz? I have done, ma. Nagaveni. Abhishek Reddy. Yes, Mohammed Anas.
Yes, sir.
I have done. Have you got 100 hertz, man? Instantaneous frequency 100 hertz you got?
No, sir, doing.
Doing. Okay. What about others? Let me ask others also. Hmm. Yes, Ananta is not there, right? Bharati is not there. Bharati? What about Danya?
Yes, sir, I got.
You got it 100 hertz? Okay.
Yes, sir.
Yes, Ram Sai? Ram Sai? Not talking. Yes, Chandrika? Chandan? Chandan?
ಸರ್
Have you got, man?
ಸರ್ ಮಾಡ್ತಿದ್ದೀನಿ ಸರ್
ಇನ್ನೂ ಮಾಡ್ತಾ ಇದೀಯ ಎಷ್ಟೊತ್ತು ಬೇಕು ಅದನ್ನು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಹೌ ಮಚ್ ಟೈಮ್ ಯು ನೀಡ್ ಮಾ
ಆಯ್ತು
ಹೌ ಮಚ್
ಸರ್
ಟೈಮ್ ಯು ರಿಕ್ವೈರ್ ಮ್ಯಾನ್ ಜಸ್ಟ್ ಫಾರ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟಿಂಗ್ ದಿಸ್ ಒನ್ which is equal to I can write here only, right? So which is what 1 by 2 pi d by dt of what I can write 200 by t plus pi by 3, right? So people need so much of time to find out the solution for this. Yes, what is the differentiation of 200 pi t? It will be 200 pi, no? Yes or no? Next is constant it is. So it is 0. So 200 pi by 2 pi, how much it will be? I can write 2 pi into 100 divided by 2 pi, right? So 2 pi will get cancelled, it will be 100 hertz. So I can say the instantaneous frequency is 100 hertz.
So,
No?
so for the second one, what is the answer, sir?
Yeah, you tell me from your side.
So I'm getting 10 plus t.
Why you have doubt when it is simple differentiation? You should be confident. It is true only.
Okay.
Okay. So for second one, that is B, right? What we can write fi of t, which is equal to 1 by 2 pi, right? D by dt of what? Yes, what it will be 20 pi t plus pi t square, right? 20 pi t plus pi t square. So which is equal to, yes, others should also say, only few people are saying what it is. And even if I call their names also, you are not responding. Right? Yes, Pooja. Girish. Pooja is there.
So,
Ah.
so for the third one, how do we have to go about, sir?
I will come. Just think, man. It is in terms of what you just think.
So should we use cos A, cos B?
Yeah. Correct. What you said is right.
So then we have to First we have to find out cos A cos B, then substitute, then do differentiation, right?
Yeah.
Okay.
I think still I am in second one only. No, yes, 20 pi t, its a differentiation is what, 20 pi, right? So you want me to write this or others have done? I don't know. They're not responding. For the first term, it will be,
Sir, 10 plus t.
yeah, 20 pi, right, divided by 2 pi is the first term. And second term is what? Pi t square. It will be 2 pi t, right? Differentiation of pi t squared as what? 2 pi t divided by 2 pi. So which is equal to what I can write?
10 plus t, sir.
Yeah, 10 plus t. So this is the expression for instantaneous frequency, right? So
Sir,
now
is the third one 100 minus 5 cos 2 pi t?
I will come, man. I will come. I need to take others also. Now still I need to tell about this. See here it is 10 plus t, na? I need to substitute the value of t. Right? When t is 0, what I get? Yes, when t is 0, it is 100 hertz, 10 hertz, right?
10 hertz.
Yeah, when t is equal to 0, I can say the instantaneous frequency. You all should write like this in the exam. If they ask, you should not write just 10 plus t. Okay, you should write when t is 0, it will be how much? 10 hertz. So as the value of t increases, what happens? The instantaneous frequency increases linearly or not? Yes?
Yes, sir.
As the value of t increases, even the instantaneous frequency also increases linearly. So that point to be written. Okay. So at what rate it increases, you should write. Okay. So what we can say is Fi of t increases linearly at a rate of 1 hertz per second. Is it fine? Fi of t increases linearly, okay, linearly at a rate of how much? 1 hertz per second. Okay, so let us now take the third one. Yeah, so as far as third one is concerned, it is in terms of what? Yeah, you can treat this as, see, first one, right? Cos of 200 pi t is there, then cos of 5 sine of 2 pi t is there. You can treat this as A. Okay, this as A, and this one as what? B. Similarly, this side is also sine of 200 pi t is there, right? Yes or no? Then sine of 5 sine 2 pi t is there. We can take this as A, the same thing, right? It is B. So it is in what form? Cos A cos B plus sin A sin B. So cos A cos B plus sin A sin B can be written as what?
Cos of A minus B.
Yeah, very good. Cos of A minus B. So you have to simplify that, then you have to write that cos of A minus B to be differentiated. Okay, to find the instantaneous frequency. Is that fine? So for the third case, it is in what form I said? It is in the form of cos A cos B plus sin A sin B, right? Third case is in this form, cos A cos B plus sin A sin B. So this is equal to what I said? Cos of A minus B, right? Here what is A and what is B? A is equal to 200 pi t, right? Yeah, somebody asked something.
Sir, in the B part, why did you say it's 1 hertz per second, sir?
Yeah, if you take t is equal to 1 second, 2 second like that, na?
Oh, yeah.
T is 1. It means 10 plus 1, 11 hertz, right?
Starting from 10 hertz, it increases linearly at 1 hertz per second.
Yeah, I said Fi of t increases linearly at a rate of what?
1 hertz.
1 hertz per second.
Yeah.
So A is 200 pi t, right? And what is the value of B? Yes, B is how much? It is 5 sine 2 pi t, right?
2 pi t.
Yeah, 5 sine of 2 pi t, right? So I can write this as cos of 200 pi t, right? Minus 5 sine 2 pi t. Okay? So this is my theta. This is my theta I of t. So now you can write the expression for Fi of t, and so what we can write? Fi of t is equal to 1 by 2 pi d by dt of s d by dt of what? 200 pi t, right? Minus 5 into sine 2 pi t. Yes, Bhargav, can you tell the differentiation of this man? Bhargav?
So is the answer 95 hertz at t is equal to 0?
Yeah. Yes, I asked Bhargav, na? Bhargav is there? Yes, is it written? Shall I scroll up? Yes, Bhargav is there. No, Bhargav. Yes, what about Aditi? Aditi. Yes, Ananta.
Yes, sir.
Yeah, can you just tell me the differentiation of this term, man?
Yes, sir. 200 pi by 2 pi into t.
1 minute, right. So the first term is what? D by dt of 200 pi t will be what?
200 pi by 2 pi.
200 pi divided by 2 pi.
2.
Right? Then
Yes, sir.
minus. Yeah, what is the differentiation of
Minus cos
2 pi t?
minus 5 into
2 pi into?
yes, sir. Cos 2 pi t.
Why you are struggling so much? Right?
Yes, sir.
Yeah. So this is equal to what? It will
Yeah,
be
5 pi cancels and then
it
100.
will be 100, no?
Yes, sir. 100 minus 10 pi cos 2 pi.
100 minus
10 pi.
10 pi. Yeah, 100 minus?
10 pi cos 2 pi t.
No, here also 2 pi should be there, no? So
Nah,
2,
yes.
2 pi will get cancelled, man. Okay.
5 cos 2 pi t.
So it will be 5, right?
Yes, sir.
Cos 2 pi t. So this is the expression for instantaneous frequency, right? So this is what we can say when T is 0, so cos 0 is 1. So 100 minus 5, it will be how much? 95. Right? Yes or no?
Yes, sir.
95 hertz you will get. Then
Yes, sir.
what about when T is 1 by 2? What is the value of cos pi?
Only, sir.
Huh?
95 hertz only.
What is the value of cos pi, man?
100, sir.
-1,
100
sir.
hertz.
Sir, no.
It'll be 105 hertz, sir.
Cos pi, I am asking cos pi.
Oh.
That time 105.
105.
See, cos pi is -1 now. Then it becomes 100 plus 5, right? Yes or no?
Yes, sir.
Minimum is 95 to how much it is? 100 plus 5 is 105 hertz, right? So it oscillates between these two values. The instantaneous frequency oscillates between these two frequencies. Yes, is this fine?
Yes, sir.
Okay, let me take one more problem. I hope you will have noted this. Yes, here you should write when t is 0, what happens? When t is 1 by 2, you will get cos per rate, that is -1, you will get 105 hertz. Okay. Yeah, take down another problem. So I think this is the third one example. Okay. So have a note of this message signal. Okay, this is my M of t signal. Okay. Note down this. So for the message signal M of t, shown in the figure, okay, the first case, if M of t is frequency modulated, on a carrier with the frequency 10 power 6 hertz. Okay? The first case is if M of t, okay, is frequency modulated with a carrier frequency of how much I said? 10 power 6 hertz. 10 power 6 hertz. Okay? With a frequency deviation constant, that is kf, which is equal to 5 hertz per volt. 5 hertz per volt. Okay. So what is the maximum instantaneous frequency of the modulated signal? What is the maximum instantaneous frequency of the modulated signal? So you have to find out what is Fi of t. The maximum Fi of t. Okay. This is the first case. So second case.
So maximum instantaneous frequency of
The modulated signal.
okay.
Okay, this is m of t is given, and he has given what is the carrier frequency, and he has given what is the frequency sensitivity factor, that is kf. So you need to find out what is the maximum instantaneous frequency of the modulated signal. Okay, this is for when m of t is modulated by, that is fm. Okay, the same case. The second case is B. Okay, that is for phase modulation. Okay, if m of t, okay, is phase modulated, if m of t is phase modulated with the phase deviation constant, okay, with phase deviation constant means kp, okay, which is equal to 3 radians per volts. 3 radians per volts. So you need to find out what is the maximum instantaneous frequency for this one. Okay. Fi of t is equal to what? What I can say maximum. Yeah, try to find out from your side. A second case is clear. If m of t is phase modulated with phase deviation constant, that is the value of kp is given, it is how much? 3 radians per volts. What is the maximum instantaneous frequency of the modulated signal? I hope you noted, na?
Can you show the figure 1 second?
This is a figure, m of t. So its maximum amplitude is 10 power 5. It varies linearly from 0 to 1, then it becomes constant. Then after 3 seconds, again it starts falling, right? So 0 to 1, it increases linearly. Then it becomes constant. Then from 3 to 4, it decreases. So we need to find out what is the maximum instantaneous frequency for this message signal, right? When the carrier frequency is of this much and the frequency sensitivity factor is of this much. Yes, how do we express the instantaneous frequency for FM signal? What is the expression we write?
FC plus KF into AM cos 2
Yeah,
pi.
use that formula and write it.
So what is FM here, sir?
Huh?
What is frequency of message signal here?
Why you wanted to know the frequency of the message signal? It is not at all required only. See, Fi of t is equal to Fc plus Kf into m of t, right? Yes or no?
Yeah.
Yeah, he has given everything now. Just substitution only it is.
Sir, is it 10.5 into 10 raised to 6?
1.5 into 10 plus.
Yeah, it is 1.5 megahertz.
Oh, yes, sir. Yes, sir. Yeah.
So just I scrolled up. Let me write. It is direct substitution only. For looking, the problem looks very big. Okay, looking at the picture and this one. But solution is very simple. Okay. So write the expression for Fi of t. So what it is? Fi of t is equal to Fc plus Kf into m of t, right? Kf into m of t. Yes or no? This is the expression for Fi of t, right? So now let me write, is asking maximum instantaneous frequency, right? We will write maximum Fi of t is equal to the maximum value of this. Okay, maximum value of Fc plus Kf into m of t, isn't it? Yes, is this clear? Yes, I am asking you people only, is this clear?
Yes, sir.
Yeah. Just what you can write, how much is Fc? Yes, how much is Fc? Carrier frequency.
6.
10 power 6.
Yeah, 10 power 6, right? It is 10 power 6 plus, what is the value of Kf?
5
Kf, yeah, 5 hertz per volt, right? 5 into the m of t value, maximum, right? Maximum you rate. It is how much? It is 10 power 5, right?
Yes, sir.
That's all. If you do this, how much you will get? It is 1.5 megahertz you will get. Yes, is it simple or is it difficult? Yes, I am not getting any response. Neither simple nor difficult. Yes, is it difficult?
No, sir.
Only Kuber, Prajwal and few people are talking. I don't know what others, another 45, 50 people are dead. Huh? Try to be active, try to involve in interaction with the teacher. Every time I need not call your names and probe you to ask questions or answer. When I ask something, you people should come forward and say, yes, this is what the answer is. Okay? Otherwise, what? Then what is the difference between you people and animals? If you don't talk, if you don't interact, right? I expect you people to interact with me. Yes, what is the solution for second one? How do we find the instantaneous frequency when it is phase modulated, right? Yes,
Sir,
what?
we need FM for this, no, sir?
Huh?
We need
Yeah. What is the expression I have written for theta e of t, right? Modulated phase will be equal to, what is the expression we have written?
2 pi FCT plus KP MT, M of T.
Kp into mt. That is the phase, right? How phase and frequency are related?
1 by 2 pi dt, d by
Yeah,
dt
d
of
by dt of theta e of t, right? Yes, to do that. So with respect to that, can I write Fi of t as, right? Fi of t, this is for PM, okay? Fi of t is equal to Fc, right? Plus Kp divided by 2 pi, right? Into d by dt of what? M of t. Is this fine? Yes, I'm asking, is this fine? This is the instantaneous frequency, Fc plus Kp by 2 pi d by dt of M of t. There's no answer for this. Yes, is this clear what I have written? Hello?
Yes, sir, it's clear,
Wow.
sir.
Oh, so much time. Like Prajwal, Maureen, Kuber is taking so much of time means I don't know about others, whether they are there with me or not, because they are not at all responding, even if I call their names also. Okay, fine. Now what we need to find out? We need to find the maximum, right? The maximum instantaneous frequency. Okay, during what interval of m of t the maximum instantaneous frequency will be achieved? Looking at the figure of m of t, is it possible to say
At
what interval?
between 1 to 3.
Yeah, I think it increases, no, linearly increases. M of t increases linearly from what to what? It's 0 to 1, right? When t varies from 0 to 1, it increases linearly from 0 to the maximum value of 10 power 5. After that, it becomes constant, isn't it? Yes or no?
Yes, sir.
It is constant, no? From 1 to whatever the value next I written 3, it is constant only. But where it is increasing linearly, 0 to 1, right? When t varies from 0 to 1, it increases, m of t increases linearly from 0 to that value, 10 power 5. After that, it becomes constant. Again, after t 3 to 4, it decreases, right? So I can achieve the maximum instantaneous frequency over the interval 0 to 1. Okay, so have a note of that. Have a note of that. Note on the maximum. Okay, the maximum value of Fi of t, that is the instantaneous frequency, is achieved for t is achieved for t for what interval? 0 to 1.
0 to 1.
Yeah. So in this case, the value of d by dt of m of t, d by dt of m of t will be equal to 10 power 5. That is the maximum value, right? M of t. So we can write, hence we can write the expression for the maximum instantaneous frequency for this will be equal to what? FC. FC is how much? It is 10 power 6, right? 10 power 6 plus what is the value of Kp they have given? Yes, what is the value of Kp?
3 radian per volt.
Yeah, 3 radians per volt, right? 3 divided by 2 pi. So what is the value of d by dt of m of t? It is 10 power 5, right? So if you simplify this, how much you are going to get? Quickly, anyone can say? Yes, how much time you need to simplify this? 10 power 6.
1.047 megahertz.
Yeah, 1 point. Can write 1.048. I will round off. Okay, megahertz. Okay, so this is the maximum instantaneous frequency. Yes, is this fine? So why I have done this exercise is, it is very important to understand how the instantaneous frequency, okay, of the carrier signal varies with respect to message signal. Okay. So now let us try to draw the waveform of FM and PM signals. Okay, by considering sinusoidal message signal. Yeah. Okay, this is my M of t. Yes, how do we draw FM signal?
Sir, can we do this next class?
Yes, sir. Short break, sir.
Okay. Okay, do one thing. You people only should write. I have written M of t, na? So you should be able to draw FM signal and as well as PM signal with respect to this message signal. Okay. You people should show in the next class, that is tomorrow. Okay. Yes, is this fine?
Yes, sir.
I'm asking, is this fine?
So what should be represented in that?
This is the M of t, man, sinusoidal signal, right?
Okay.
I asked you people to draw FM and PM waves. How the frequency modulated signal will look like and how the phase modulated signal will look like.
Okay, sir.
You can draw unmodulated carrier frequency also. Then you can draw the FM and PM signals.
Okay, sir.
Okay, you draw and come. Fine. So with this, I will stop.